Hi everybody, this is Mrs. Baxter, and today we're going to review combining like terms. And so if you were in class, you'll remember that we did a little activity on the whiteboard and talked about hamburgers and milkshakes and french fries and making sure that things are grouped together appropriately. And so what we're going to do now is go ahead and fill out this our notes here that you can use for the quiz that will come up in about a week. Okay, so like terms, what does that mean? Well, that is the elements of an equation that match. So go ahead and fill that out. Okay, and then some additional vocabulary. Constants only match other constants. Now remember, a constant is a number. Okay, so I'm just going to put a little note here. It's a number. So some examples of a constant are 7 and 10, or 4 and 1. So any number. Non-examples would be you cannot combine 7 and 7x. They do not work. Or we cannot do 4 and 1x. Those do not combine. All right, variables. Variables mean letters. Okay, so only match when they have the same variable and exponent. So remember, an exponent example is x raised to the second power. That is your exponent, okay? And I know I'm writing really tiny here, but that's just a little reminder, okay? So an example of variables that match each other would be 3x matches 3x. And then let's try another one. How about 2a squared and 6a squared? Note those letters / the variables are also known as the variables, and the exponent, so a squared, is the part that matches. So let me see if I can highlight it here. So this part right here and this part right here, these two match. This matches and this matches. So non-examples of this would be 2b and 2a. Notice those letters, they do not match, so we cannot combine those. They are not like terms. Another non-example, or things that do not combine, are 3x and 4x squared. So even though they both have x, they have different exponents. So note right here, there is an exponent here and there is not an exponent here. Okay, they have to be the same. All right, and so when we're combining like terms, we can say that like terms can be combined or simplified by adding or subtracting. Terms must have the same variable and the same exponent to be combined. And then we use what's called the commutative property, which allows us to rewrite the expression in a different order without changing the overall value, okay? So you'll see what I mean by this here in a little bit. Let's do a couple examples, okay? Let's look at number 1, 3a plus 4a. Well, they both have variables. Do the variables match? Yeah, they sure do. 3a right here, 4a, they match. We can combine them. So 3 plus a plus 4a is equal to 7a. Okay, so we're just going to add the constant. This is the constants but the variables have to stay the same, okay? All right, let's look at another example. Do you see here any matches? Anything that can be combined and anything that can't? If you said 7y minus 3y can be combined, you would be correct because we have the same variable here, the same variable here. Notice there is nothing here. It is different. We cannot combine it, okay? So let's combine our 7y minus 3y. That's going to equal 4y. And because we can't combine a 2 with anything, we have to leave it in the equation and it stands alone, okay? All right, let's look at 3, example number 3. 3x minus 4 plus x. All right, do you see any similar or like terms that we can combine? If you looked at the x's right here, and there's one here, those two are like terms. Now, I know we don't see the number right here. There's nothing there. There's no constant, like there's a constant here. Remember my favorite number, the number 1. That you can assume it's invisible, but it's there, okay? So that would be the same as saying 1x. So when we combine them, the commutative property says that even though they're not right next to each other, we can still add them together. You're going to use the symbol in front of the x here in order to create, to combine those like terms. So I'm going to combine 3x plus x. That is going to equal 4x. And because there is no match for a negative 4, we're just going to carry it down. And this is our new equation. We're just going to rewrite this expression using the commutative property, saying that we can move things around. It does not change the equation. All right, let's get a little bit tougher. All right, when you're working with a problem that has multiple terms in here, like you see here, it's okay to do things like single underline or double underline to categorize them or put them together. So remember, milkshakes and fries, okay? So here we go. We've got, I'm looking at this constant. We've got 5 here. This next one, nope, there's a variable, can't do it. All right, do we have another one that's just a constant? We do. Here's a negative 8, okay? Now, I'm gonna go back and I'm gonna look at my other one. I think I see, here's a negative 3s, and I also see a 6x. Sorry. So we can combine these two, and we can combine these two and create a new simplified equation, okay? So when I put my order in, I have my 5 minus 8, which is going to be negative 3. And then I've got my negative 3s plus 6s. When I combine those together, I'm going to get negative 3s. Now remember, even though these constants are similar, they do not have the same variable. So this one does not have an s, this one does have an s, so you have to leave it like this. This is your answer, okay? I think what I'm going to do is I will highlight this. This is our new answer, okay? All right, let's look at one more example. I'm going to start looking, I'll start at the beginning, and I'm seeing 4x squared right here, okay? It's important that I pay attention to this x squared piece of it, all right? Can I find any other x squareds? Well, as I look along, yep, here's my other x squared. So I can combine those two. I'm going to go ahead and do this to show you another example how we can highlight. I'm just going to put one underline with those. Remember, I have my imaginary 1, so it's like we're adding 4 plus 1. We're going to add those constants together, but our x squared is going to remain the same. So let me add those together. 4 plus 1 is 5. Leave it as x squared. And then I'm going to say, oh, here's one with just a negative x. Here's one with an x. I can combine those two together, and I'm going to get plus 2x. And this is our new simplified equation. So it's almost like saying I have 5 French fries and 2 burgers. I'm not going to make a burger. Can combine those two, remember, to make up something completely different. We have our fries, we have our burgers, that's it. All right, so you should have a homework assignment for this day. It should be fairly straightforward. If you have any questions, let me know. All right, go to it. You guys got this.